So the graph look like this. The gradient function dy over dx is equal to 6x squared. And when you integrate it, you got y equals to 2x cubed plus c. And you can see all the different curves. So a sample of 6 values of c. So like 1, 2, 3, 4, 5, 6 different values of c. You have 6 different curves. So this one plus 5 because it passes at this point 5 there. And this one will be plus 4, plus 3, plus 2. Example 3, find the equation of the family of curves with gradient function dy over dx equals to 3x minus 1. So the index of x, that means the power of x is 1 there. So in the 3x term, the power of x is 1. So when you integrate, you add 1 to the power and it becomes 2. So plus 1 plus 1, it becomes 2. And you divide by that new power. So it becomes 3x squared divided by 2. And this constant term minus 1, it has no x. Well, you can say x to the power 0. So when you integrate it, you just add an x to it. So that's why it becomes minus 1 times x, which gives you minus x. So you get minus x, and then plus the constant of integration. And you can only find this constant of integration when you have additional information. So that's your answer. You leave your answer like that. And when they mark it in exam, they mark each term. Now it's your turn to try these ones. Find the equations of the family of curves with the following gradient functions. Number 1, dy over dx is equals to 3x squared plus 4x. Number 2, dy over dx is equals to x squared minus half x plus 1. And number 3, dy over dx equals to x bracket x plus 2 bracket close and then x minus 3. So try this, and then when you finish, you come back and check your answers. Welcome back. So this is the answer you would have. Y equals to x cubed plus 2x squared plus c. Don't forget to add the constant of integration. Note when you differentiate 3x squared, you add 1, it becomes 3x cubed. You divide by 3. 4x to the power 1, you add 1, it becomes 4x squared, and you divide by 2. And for number 2, your answer is y equals to x cubed over 3 minus x squared over 4 plus x. When you differentiate plus 1, you just get plus x because you imagine it's an x to the power 0 there. So you add 1, it becomes x to the power 1. And then you add the constant integration. And for question number 3, you multiply out the brackets. X times x gives you x squared. X times minus 3 minus 3x. 2 times x is plus 2x, and 2 times minus 3 gives you minus 6. So you simplify that, you get x squared minus x minus 3. And now you can integrate. When you integrate x squared, you get x cubed over 3. When you integrate minus x, you get minus x squared over 2. And when you integrate minus 6, you get minus 6x. And then you add the constant of integration. Finding the value of c, the constant of integration. Example 1, find the equation of the curve which passes through the point 1, 2, and has the gradient function given by dy over dx is equals to x squared minus x plus 2. So we want to integrate first, and then substitute the value for x as 1, substitute the value for y as 2, and then we can find c, the constant of integration. So we have dy over dx is equals to x squared minus x plus 2. Integrating that, integral of x squared, it gives you x cubed over 3. Integral of minus x, it gives you minus x squared over 2. Integral of 2, it gives you 2x. And then we add the constant of integration. Now we want to find this constant of integration. That's what we want to find. Find C, the arbitrary constant. We have been given some information. We've been given that the curve passes through 1 and 2. That means x is 1 and y is 2. So we put y is 2 and put x is 1. Substitute x is 1 and substitute y is 2. So we'll get this equation there. 2 equals to 1 over 3 minus 1 over 2 plus 2 times 1 plus c. Put all of this together in your calculator. Use your calculator to do all the simplification. And then you will get the value of c to be 1 over 6. You can use 6 as a common denominator if you want to put all of this together. But using your calculator, you can work all of this out and take that away from 2. And that gives your c to 1 over 6. So you can write your equation as y equals to x cubed over 3 minus x squared over 2 plus 2x plus c, which is now 1 over 6. So that's your equation of your curve, which you can plot on your graphics calculator and see what it looks like. Here are 2 questions for you to try. Question number 1, find the equation of the curve with gradient function dy over dx is minus half x, and it passes through the point 2 minus 2. And question number 2, find the equation of the curve with gradient function, and it passes through 2 and 1. First pause and have a go. When you finish, you come back to check your answer. Welcome back. For number 1, you have dy over dx equals to minus a half x. So you have y equals to, when you integrate, you add 1 to the power, it becomes x squared divided by the power, it becomes minus x squared over 4 plus c. Substitute y is minus 2 and x is 2. You get this next expression, which you simplify to get c to be minus 1. So you can write it as y equals to minus x squared over 4 minus 1. And for question number 2, you multiply it to remove the brackets using first, outer, inner, and last. And you get x squared plus 3x plus 2. You integrate that. Integral of x squared gives you x cubed over 3. Integral of 3x is 3x squared over 2. And integral of 2 is 2x. Now you substitute the value for y. Y is 1. X is 2. So wherever you see x, you put 2. And you get that expression, that equation, and you will use your calculator. Put all of this in your calculator and you simplify it, and you work out the value for c to be minus 35 over 3. So you can write your equation like this. Y is x cubed over 3 plus 3x squared over 2 plus 2x minus 35 over 3. Notation for integration. We know that dy over dx is equals to 2x. So, which means when you integrate it, you get 2x squared over 2, which ends up gives you x squared plus c. So when you integrate that, you get x squared plus c. So another way of writing integration is to use this sign. It's called the integral sign. It's like a stretch S, that like sign like that. The integral sign, that's what it stands for. The integral sign. So when we put that sign, it means integrate with respect to x. And the dx means, so we read this as, this d and x, we say dx. It must be included to indicate that the variable is x. So we can have integral of 2x dx. If it has to do with a different letter, it could be integral of 2r dr. So it has to be included, the dx. In full, we say that we are integrating with respect to x. We're integrating with respect to x. So for example, find the integral of 3 dx and integral of 3 dt. So for the first one, we are integrating with respect to x. So when you integrate, imagine this, it's like 3x to the power 0. So 3x to the power 0, you add 1 and divide by the 1. So you just get 3x. So we get 3x plus c, the constant integration. This one is integral of 3 dt with respect to t. So we integrate with respect to t. So 3 dt becomes 3t plus c. Example 3, integrate x cubed minus x squared plus 2x minus 1 with respect to x. So the notation for integration must be written, this stretch, this symbol there, the integral sign, looks like that. So it means we integrate that. Instead of writing the word integrate, we just write the sign integrate. So when you integrate x cubed, you get x to the 4 over 4. Integrate x squared, you get x cubed over 3. Integrate 2x, you get x squared over 2, but the 2 would cancel. Integrate minus 1, you get minus x. So whenever you integrate a number, you just add an x in front. And then plus the constant of integration. Now that we have done the integration, we do not put the sign anymore. We don't put the sign here anymore because we've already done the integration. So your answer now is x squared, x to the 4 over 4 minus x cubed over 3 plus x squared minus x plus c. Now it's your turn. Find the integral of 3x cubed, 3x squared minus 4x plus 2, and the part A and part B. And then you do question 2A and 2B. And when you finish, you come back and check your answers. Welcome back. And here are the answers. So if you mark it and check the answers. So for the first one, x cubed minus 2x squared plus 2x plus c. For part B, that's the answer there. For 2A, that's the answer for 2A. And that's the answer for 2B. So to summarize, indefinite integration is the reverse of differentiation. A constant of integration C or arbitrary constant is always included. Indefinite integration is used to find a family of curves. To find a curve through a given point, the value of C is found by substituting the value for X and Y. So this one is very important. You write this down. That's what is very important when you want to find. And there are two notations. dy over dx equals to 4x cubed, or you can write it as integral of 4x cubed dx is equals to x4 plus c. In this case, y equals to x to the 4 plus c. Here are some math jokes for you. Have a read at that and look at this and look at this one.